Hey there, everybody. The purpose of this video is to get you some solutions to this little homework about changing fractions to decimals. Yeah, it looks like we're adding a bunch of fractions together and then rounding off our final answer. So I'm going to go ahead and look at this first one, combine the first four. So what I'm going to do is I'm going to just open, just like we did in class, I'm going to use Google as a calculator like we were doing. We seem to enjoy that. And if I combine, now remember, make sure to catch, let me go back to the homework here. The difference between this series and the one we were doing in class is this one has alternating signs, you know, adding, subtracting, adding, subtracting, adding. So make sure that you were catching those. The first one's addition, the second one's subtraction, the third one's addition in this case. So let's make sure I did it right. Addition, subtraction, addition. Yep, there it is. Notice how when I enter this into Google, Google inserts parentheses. I'm going to talk about that in soon enough. Some of you might know why they're there. Some of you might not. At any rate, the point is right now we have to round this puppy dog off to the 10,000th place. So you got tenths, hundredths, thousandths, 10,000ths. So I'm going to that place, which means I look at that place, and that tells me to leave that as it is. So this would be 7,833 10,000ths. Or as many of you are getting used to saying, 0.7, what did I just say? 833. There we go. 7,833. I'll just put them next to the answers here. And I'll make them bold so we can see them better. All right, good. 6 fractions, same exact idea. And what's so nice about problems like this in Google is you just keep the pattern going. Minus 1/6 plus 1/7. Okay. And this one looks like we're going to round it a 10,000th place again, which means that's going to stay a 5. 7,595. 7,595 10,000ths. 595 10,000ths. Notice it got smaller than the previous one, and this is different than what we did in class together. In class together we had the ones that kept getting bigger and bigger, but hopefully you understand why we're adding and subtracting fractions here. So in this case we subtracted a 6th and added a 7th, which we talked about in class. Since 1/7 is smaller than 1/6, we're taking away more than we're adding back. All right, all the fractions you see, so that goes up to 1/10. 1/10. So let's go back to my Google calculator. Plus 1/7 minus 1/8 plus 1/9 minus 1/10. All right, there's all the ones I see. And it looks like we're going to round this puppy dog off to 6,456 10,000ths. I forgot that number already. I got to go back and look at it. 6,456. Put it back over here. Okay, again, it got smaller. All right, and then lastly, I said do that, then throw 5 more on. All right, so we're going to go plus 1/11th, minus 1/12th, plus 1/13th, minus 1/14th, plus 1/15th. All right, and then notice what it does now. Now it goes up. 7,254, remember, 4. 10,000ths, 0.7254. Let me write that down. Let's chat a little bit about that. And you got to remember, the reason these 3 were all dropping was because when we went from 4 to 6 and then to 10, I believe there are 10 fractions up here. No, there are 9. Excuse me, there are 9. But regardless, we kept taking more away than we were adding each time. So for example, right here, these first 4, we added these 2 together, then took some away, but then added not quite as much back, which is going to make it get smaller than the previous 2. Same thing for the next 2. We're going to take some away and then not add more back than we took away. Here is even more interesting because we're taking away an 1/8 and a 10th, but only putting a 9th back, which makes it even smaller. But then in this last one that we did, if you look at the actual fractions we added 3 positive ones and subtracted 2 negative ones. And that's kind of fun. That's kind of fun because we added more than we took away, which is why your sum actually got bigger. So this is called an alternating harmonic series, and because of that behavior, all the discussions we had in class kind of go out the window. We talked about the harmonic series always getting bigger, and no matter how many fractions we add, we can always make it bigger and get bigger than 1 and bigger than 2 and bigger than 3, and that was fun. And then yesterday in class we proved that we never can get anywhere with the geometric series. Even though it's always getting bigger, you never quite get to where you're going. That was Zeno's paradox. This is a totally different kind. This is one that gets bigger and smaller and bigger and smaller and bigger and smaller, and it never really goes anywhere. It just kind of almost pseudo-randomly jumps around. And I mentioned in class, this is what classes like calculus attack, is how to rectify and describe that. But that's about as far as I wanted to go with it. I just wanted to make sure that you can actually turn these things from fractions into decimals, and then use some technology too where appropriate. All right, we'll see you in class.